All right, folks, today we're going to talk about sine, cosine, and tangent as independent functions based on what we know already about the unit circle. So after the test, you were given a little half sheet that asked you to find exact values of sine, cosine, tangent for the special triangles at the values of 30, 60, and 45 degrees. And then I asked you to change those to decimals as well, because that's going to help us with the graphing here. Okay, what we're going to do is use that combined with symmetry on this unit circle to fill out the table. So our exact value is going to go in the first column, and our decimal is going to go in the second column. That's our approximate value that we rounded to. Okay, so using your paper, these three represent to your triangles, and we're only focusing on sine. Sine of a 30-degree triangle is 1/2. Okay, and then our second one was the 45, and that was square root of 2 over 2. And then the 60-degree triangle has the longer sine value. That's our square root of 3 over 2. Okay, but then we're going to talk about also the original 4 points on the unit circle. So here, the y value of this is 0 itself, and the y value of this one is 1. And then we just do the decimal versions of that, and I had you just put them in your calculator. We know half is 0.5, but this was about 0.71, and this one was about 0.87, then 1 is exactly 1. Okay, so that was what was on your sheet, but now we're just going to use symmetry to answer the other questions. So all of these angles just represent these points as you move around the circle here. So my next angle is now I'm moving to this one. That's my 2/3 pi. And the symmetric value here is with this one. It's at the same height, so it is square root of 3 over 2. Okay, the next one is symmetric with my pi over 4 value, which was square root of 2 over 2. And then this 5/6 is symmetric with my 1/2. Okay, at pi itself, we're back to a height or a y value of 0. 7 pi over 6 has some symmetry as well. This length is the same as this length, but because we're in quadrant 3, we're going to have negative values for the next chunk. So here, that's a negative 1/2. This goes with my 45-degree triangle, so it's negative square root of 2 over 2. And then this will go with my 60-degree triangle. So that's negative square root of 3 over 2. And then I'm down here at negative 1 for my 3 pi over 2. Okay, then these three values I can match up this way again. Okay, they'll be at the same height, negative and all. So this next one goes actually with my 60-degree triangle again. So negative square root of 3 over 2. And then I go to my 45, negative square root of 2 over 2. And then I go to my negative 1/2. And I end back up at 0. And we'll just fill in those decimals. So this was my 0.87. This was my 0.71, 0.5, 0, negative 0.5, okay, negative 0.71, negative 0.87, negative 1 itself, negative 0.87, negative 0.71, negative 0.5, and 0. I'm just copying the same decimals and stealing the sign from what we did on that little half sheet. Okay, so I wanted to do those with you so you could understand the pattern here, since you weren't in class to be able to ask me questions. Okay, but now what I want you to do is finish the instructions and the problems all through the front page. Okay, what you're going to do is be asked to graph this and then answer some questions based on your graph. Okay, so pause the video and complete those steps for me. Okay, so when we look at our points graphed, okay, it did say connect all the points using a smooth curve. So if you missed that, go ahead and connect them. We've got kind of this wave shape. But what I want to do is talk about what happens after these points. Okay, we've got 0 to 2 pi from our table, but we also connected them, which means all these angles in between will have sine ratios as well, and we know that. we can take the sine of 25 degrees. Okay, we've done that in our calculator in geometry. It's just not something we focused on this year. We've just focused on the nice special triangle values. Okay, but what we want to think about is what happens if we are a different direction past this 2 pi. So I've gone around my circle and I filled out all of these, but now I'm going to go past 2 pi. And once I go past 2 pi, I'm back at a positive sine value. So this is going to keep going, and we just put an arrow going up. Okay, because we know it's going positive. If I go on this side, that's a sine of a negative pi over 6. So negative, remember, means clockwise. So if I go clockwise on my circle, that's going to have a negative sine value. So this side would go down. And specifically, we're going to have our symmetry. This would be a negative 1/2. This would be a negative 0.71. And it would go through those points. Okay? So it did have a maximum, hopefully you got that, of 1 and a minimum of -1. We're going to use that to talk about domain and range. Okay, these values actually go with the range. You should have gotten -1 to +1 included, because those actually are included. And what kind of helps you think about that is back before we learned about the unit circle, sine for us was opposite over hypotenuse. If the hypotenuse is the biggest side of a triangle, then the bigger number of the fraction has to be on the bottom. So when we have a smaller number over a larger number, it's always less than 1. And we learned it can also be equal to 1 using the unit circle. Then our domain, based on this idea of we can keep going around the circle, or I can go backwards around the circle, it's all real numbers. Okay, and I want to emphasize, so I'm going to have you go back to your table here, that this row that we were looking at here, okay, this row goes with our x values, that's our angles, and this row, both of them really, is our y value. So when we talk about y, it's not sine is y because we're on the unit circle, it's because y is our dependent variable. It's the result of plugging in those angles. Okay, so the y value is the ratio, whatever trig expression we're looking at. Okay. And then how long does it take the graph to start repeating itself? Hopefully you notice the relationship with the unit circle. Okay, these values start repeating after 2 pi, because as we go around the circle, then I start repeating those same values in the same order after 2 pi. And that right there, I want you to add, is called the period of the graph. Okay, that word should be somewhat familiar from periodicity. We just didn't know what it meant. Okay, period is the length of time it takes a trig function to repeat itself. Okay, these functions that we're going to be working with are called periodic functions because they repeat after a certain amount of time or after a certain period. Okay, so another thing we're going to talk about here are some important features. Okay, so we're going to label on the graph the intercepts and the maximums and minimums. So starting here, our intercept, the first one is both an x and a y intercept. It's at 0, 0. I want you to darken that point. The next one is a maximum point, and that is pi over 2, 1. Just going the x value then the y value. Then we've got another x-intercept, that's a 0, okay, pi 0. Then we've got our minimum point, that's important. So 3 pi over 2 is the x part, the y value is -1. And then we got another 0 at 2 pi 0. And those points that we just darkened relate to the 4 points on the unit circle. And if we know those 4 points on the unit circle really well, and we know that the shape makes a wave, then we don't need those middle points anymore. We just have to remember the pattern. Okay? A couple more things here. We're going to label some stuff. On the maximum here right below, the distance from that maximum to the middle of your graph, or that x-axis here, that's called the amplitude. And it relates to the radius of the unit circle, or the radius of whatever circle you're working with. So that is 1 for us. It's just that distance there. Okay. And then we're also going to talk about how you can see the period from the graph more specifically. Okay, it takes 2 pi to start repeating itself, but it's not always obvious to see that from this 0 to this one, because it's not the same distance just between x-intercepts. It takes this full lap. Okay, so where it really comes from, or the easier way to see it, if you extend this over, I've got some more room over here, so I'm going to put it on this side. If you extend this over, okay, we know it'd do something like this, and from this minimum point all the way to this minimum point, that measurement represents your period. Okay, so either from min to min or max to max, and I'll add that here. Okay, it's really any corresponding point, but those are the most obvious to see on our graph. Okay. So now, since I did the first table with you, I'm going to have you try this one for cosine by yourself. Okay, so take some time to fill out this table, and then answer all the questions on the cosine page, and then come back to the video and we'll chat. All right, the table of values should have gotten you a graph like this, but again, we're going to talk about extending it past. So thinking about this unit circle again, if I go past 2 pi, the cosine value is positive, okay? And we're going to never go past this 1 value, so it has to go down from there. And I'm starting at 1, my x value, and it's getting smaller and smaller as I go throughout there. Okay, then on this side, we're going counterclockwise. Again, I'm starting at 1. We're talking about the x value, not the y value. So these ones are getting smaller and smaller, smaller x values. It's going down on this side as well. Okay. We're going to label those important points that relate to the 4 points on the unit circle. So that's 0, 1, just looking at x, y. Pi over 2, 0. Pi negative 1. And 3 pi over 2, 0. Finishing back right at 2 pi 1. The maximum value is still 1. Minimum still negative 1. And domain and range for this is exactly the same as it was for sine, because the same rules apply. When we talk about angles, I can find the sine, cosine of any number. I could put any angle in there. I could go any number of laps around and no problems. The range, when we think about cosine, is adjacent over hypotenuse, and again, that bigger number is on the bottom. So we're going to have a fraction less than 1. At the unit circle values, we'll have 0 and 1 pop up. Okay, again, we had a period of 2 pi. And this one's easier to see on the graph because we have 2 maximums visualized here. So I'm going to have you label this on here. Okay, the period we can see from max to max on this one pretty easily. Again, the amplitude is from that maximum to the middle. It's also the minimum to the middle, by the way. Okay, and again, that's 1. Now, one thing I didn't have you add on the first graph that I want you to add here, and you can go back and add it to the sine as well. This middle value that I'm talking about where we're measuring, it does have a special name, and it's helpful for graphing. It's called the midline. It's not an actual line that we draw on. It's just visualizing cutting our graph in half vertically. Okay. All right, and then it's asked, where is cosine equals 0? So you may have thought about the unit circle. X is 0 at the top or bottom. So that would be theta equals pi over 2 and 3 pi over 2. But also, if we look at our graph here, we can represent that in a different way. We know this is the cosine graph. We're looking at where cosine, or the y value, is 0. Again, it's not unit circle y. It's y as in the dependent variable, what's going on our y-axis. Okay, so that's when we have this y equals 0. It's basically our x-axis, or our x-intercepts, or zeros. Okay, so we'll think back and forth between the unit circle and these graphs as we become more familiar with them. Okay, now you're going to do this with tangent. I will help you with a couple things really quick before I set you free here. Okay, as you go through here, remember tangent has some weird spots. There are points that are undefined. Okay, so when you're reading through the instructions here, it says plot each point, but when you go to your questions on the next stage, it does not say to connect your points. So I don't want you to connect your points yet. I do want you to read through all the questions and answer any that you can, and we'll talk through all of them together after you're done graphing. Okay, go ahead and pause the video now. Okay, so our points look a little strange, but that's because we've got this gap at pi over 2. So undefined could show up two different ways in a graph. If we think back to our rational functions that we did earlier this year, we could have undefined or dividing by 0, remember that's where undefined comes from, show up as a whole or as a vertical asymptote. Okay, and we have to decide which one's happening based on what we see on our picture. Okay, if we think back to a vertical asymptote, generally that means we have one branch here and a lot of times diagonal. It doesn't have to be, but it's easiest to see here. Whereas a whole just means at some point the graph stops and picks back up. Okay, and that's how we really tell the difference, is we focus on the value that's undefined and we decide what's going on as we approach that value from either side. If they're doing the same thing, like getting closer and closer to a single value, then that's a whole. But if they're getting closer and closer to different values, then that's an asymptote. So here, when we look at going from this side of the pi over 2, if I follow these points, they're going up. Okay, and if I'm going this direction and following these points, they're going lower and lower, which means this has to be a vertical asymptote. So we've got to draw on this dashed line. Go ahead and do that at 3 pi over 2 as well. And so this one is a vertical asymptote. Okay, because our values on either side, so as we approach pi over 2 from both sides, we're not seeing the same number pop up. Now sometimes that's just obvious, like one's positive, one's negative. But you can have the instance of where a whole is it's positive on one side and negative on another, okay, because we could have that value of the whole right at 0. Okay, but in general, if we see opposite signs, we're probably going to have an asymptote instead. Okay, so with that in mind, this will help us draw our curve, because if I know there's a vertical asymptote here, then my curve should be guided by that vertical asymptote. So as I connect these, and now we'll actually do it with a curve, this one has to level off towards that asymptote. Same thing happens on this reverse side. Okay, I'm going to be close to this asymptote and then go through those points following the curve. And then it kind of switches the direction of the curve here, almost like a cubic, and then heads up towards the other one. Last one, same thing. And then after this, it would follow that same pattern until we hit the next asymptote. Over here, we can reverse that. It would be going this way until we hit that next asymptote value. Okay, so with this in mind, when I've got this arrow on the top, there is no maximum value. If we think about that with our triangles, just like we have been doing, the ratio over A can look like anything. There's no rules about what the opposite side has to be in relation to the adjacent. One can be bigger, one can be smaller, and it does not matter. Okay, so there are no restrictions there. Okay, same thing goes with a minimum value. Okay, again, just over A can be anything. So it can also be negative values. We learned that about the unit circle. Okay. You may have struggled when thinking about domain, knowing that there's points that are undefined. We're actually going to come back to that. For right now, the range, if there is no minimum or no maximum, our range is all real numbers. Okay, and for the graph to start repeating itself, we're going to go back to look at this graph. It does not take 2 pi. Okay, hopefully you recognize to fill this one swoop, it only takes a difference of pi. Okay, so let's add that on here. The period we can measure from asymptote to asymptote, or in the case of the tangent graph, from one x-intercept to another, or from one 0 to another. Okay, but the period is pi. Okay, so now let's go back to the domain. It's not possible to use interval notation for this. If we were, we'd have to say from negative pi over 2 to pi over 2, union pi over 2 to 3 pi over 2, union 3 pi over 2 to 5 pi over 2, union literally forever. Okay, we can't do that infinitely. But we can do it with set notation. So here's how this works. You're going to start with your variable. So that's going to be x or theta. You choose. Okay, I'm using theta because that's what they used. And we're going to just list the restrictions. So we're saying theta or x can't be, and just writing the value of the first asymptote. So that was at pi over 2, just looking at your graph. But then if we go back to our graph, they happen every period. In the case of tangent, that's every pi. So we can say, to find the next one, just add on pi. To find the next one after that, add on pi again. To find the next one, add on pi again. So we're really adding on pi any number of times, as long as n is an integer. Remember, integers are positive or negative values. So if I use a -1, -2, -3, that takes care of going backwards as well. Okay, and we'll practice with that notation, so don't worry about it too much right now. It's good to know that we're seeing values of the asymptotes at half pi intervals. Okay. Last thing we're going to do is how we use these functions to solve problems. So we've actually looked at one function already. That was our Ferris wheel. We actually wrote an equation for sine of a function. We just didn't ever look at its graph. Okay, and that's what we're going to focus on today. We're going to try to solve this equation where cosine of theta equals 0.226. On the back of the front page, what you just did is I asked you where was cosine equal to 0, and because 0 was a nice value, you were able to look at the graph and find it. Now what we're going to talk about is where sine is a not, or excuse me, sine, cosine, or tangent is a not nice value. So step one is you're going to sketch a picture. So draw a little T table for me here. And we're going to think about the unit circle to graph these, okay? Because I want you to be able to graph them from memory, just talking about these 4 points in order. So I'm starting at 0, that's 0 degrees, and I'm just talking about what's happening with the cosine, which is the x value. Okay, so the x value here is 1, so my first ordered pair is 0, 1. Okay, then my next point, I'm going to pi over 2, and the cosine there is 0, so it comes down to 0. Then I'm going to this next one, and here the cosine value is -1. So at my next value, I'm at -1. And then I'm going to the next one. My cosine is back to 0. And then back here, my cosine is over at 1 again. Okay? Basically, if you know where it starts, and you know where it makes a wave, we're always going to alternate between 1, 0, -1, 0, 1, -1, and so forth. Okay, so here, we'll connect it with a smooth curve, knowing it goes down afterwards. And we're going to just do the same thing over here. So if I'm already at the maximum, it has to go down. And if it has to go down, it has to cross over the x-axis, so that's our next point. And it goes all the way down to -1. And then it has to come back up after that, so it has to cross the x-axis again, and then come back up to the maximum. And then connect it with a smooth curve. So there's cosine. And now we're going to think about where is that cosine of 0.266. So here, with that, cosine is 1 here, Cosine is 0 here. 0.266 is somewhere along this line. So I want you to draw on that line for me and label it. So this was our cosine theta. This was our 0.226. And we can solve equations by where those are equal to each other. Okay, where they're equal to each other means the intersections. So we've graphed it where I can see 4 possible answers. Okay, there are infinitely many because this is going to repeat over and over and over again forever. So it's not going to ask you to list all of the answers. It's going to ask a specific question. So we're supposed to find 2 solutions closest to the one they give us. Okay, so it says one solution to this is 1.343. So that is my angle, which means that's my x value. So it's my x value of one of these points. It's positive, so it has to be this one or this one. And this is a value in radians. Okay, here we know that this is 3.14 radians pi. Okay, so it can't be over here. It has to be this one. Okay, and I'm going to show you how you can visualize that with your calculator as well, because we struggle sometimes to think about radians as regular numbers instead of pi values, which is fine. Okay, so let's set this up in our calculator, because we're going to find the 2 that are closest to this, which means I need this one on the left and this one on the right. So our calculator will help us do that. So what you're going to do every single time to solve equations using your calculator is you're going to put the left side in the y1. Okay, and you can just use x, and then you're going to put the right side in the second line. Okay? And if you do nothing else and hit graph, you're going to see lots of problems. Okay, because this right here was in radians, we have to change our mode to radians. So what you're going to do next is hit mode and change from degrees to radians. Okay, and we'll be in radian mode for much of this chapter. Okay. From there, what we want to do is make sure that we're picking a window that's appropriate. Right now, if I do my normal zoom 6, this 10 by 10 window, it's not awful, don't get me wrong, but it's not very zoomed in. It's hard to see what's happening since this 0.226 is so close to 0. So go to your window for me, and what we're going to do is from negative 2 pi to 2 pi, that's our 2 laps, one forward, one backwards, and literally type negative 2 pi, and then positive 2 pi. And then our y minimum and y maximum, we're at 1 and negative 1, but let's give some breathing room and call it negative 2 and positive 2. And then just hit graph. Now we can see it way more clear, and it looks almost identical to what we have. Okay, ours is a little bit better. Okay, from here, we're going to do the intersections. So second, trace, intersection. And then your cursor is going to pop up usually around the x-axis, or the y-axis in this case. And then you're going to just hit enter 3 times. And it gives us that first number, and I told you we could use our calculator to figure out that that was our intersection that they gave us, because that's our 343 that they gave us. Okay, so that tells us I want one to the right of that and one to the left. So we're going to find those with the same process. Do second, trace, intersection, and then all you need to do is arrow over with your cursor until you're closer to that next intersection. As long as you're over this hump here, you'll be good. And then enter, enter, enter. So my next one is at 4.940. Remember, this is my value of y that I was given. Okay, so I just want the angle measure. Okay, it says thousandths, that's why I'm using 3 decimal places. So about 4.940. Then we're going to do that on the other side. So do second, trace, intersection again. And then if you go up, you can travel along your curve faster. That way you don't have to go on the sine or the cosine wave. You can just go on the line. And we're getting on top of this one. And then enter, enter, enter. And this one I hope looks familiar to you. It's the same angle but negative, because we know that the opposites theorem tells us that cosine of an angle and cosine of its negative angle, or of its opposite, are exactly the same. In this case, they're exactly that 0.226. So those are the theta values that solve it. Now, I skipped over this intentionally. It says, how could we find solutions if the instructions didn't say closest? Okay, so if we're focusing on just any place where it hits this, what we can use is the idea of our period. From maximum to maximum, we know is 2 pi, but that's from any point to another corresponding point will be 2 pi. So I can always add or subtract the period for the function to get more solutions if I don't ask for them closest. Okay, so for sine and cosine, just add 2 pi. For tangent, we would want to add pi instead. Okay, but these ones I will ask you for the closest. That's how it'll look on your homework. Okay, sine is going to work the same way, so I'm going to skip over that one, and we're going to just do this last one together. Okay, so it says one solution to tangent is this. We're going to sketch it first. Okay, so let's draw a little graph. And we're thinking about the unit circle to graph this. Okay, so 4 points starting at 0. So remember, tangent only has 2 possibilities, 0 or undefined at these points. So here, we're starting at 0, 0. Then at pi over 2, we're undefined. That was a vertical asymptote. Then we're back at 0. And then we're undefined. Okay, and we're going to do the same thing over here. Okay, so if I'm going clockwise, pi over 2, that's at undefined. Then a point at 0. Then undefined. And we're just going to make our pattern. It looks kind of like a cubic. Starts low, swoops and goes high. Okay, so now what we're going to do is we're going to find what we're trying to look at. So we want this tangent to be equal to this. So that's going to be our horizontal line. So we want it to be -2. You get to pick what you think -2 looks like. And these are my intersections. Okay, it gives me one of them. It gives me one of them being 2.084. So it's probably the first positive one, but we're going to check and make sure in our calculator. Now, if it is this one, then we have to make sure we have the closest, which would mean one to the left and one to the right, which means we would need an extra swoop. And we need it anyway, so go ahead and put your next 0 and our next asymptote, and then swoop one more time. Okay, we need it anyway because I know this is positive. I have to have a positive one. We need at least 2 on this side. Okay, so let's now talk tangent. Clear out what you got. And we're doing tangent of x. And then the negative 1.773. For the most part, you're not going to have to change your window, but in the case of tangent, we don't have a maximum or a minimum. So you may have to change your window on these ones to be more than 2 or -2, depending on what your value is. Okay, so I'm going to make a little note here. Window may have to be changed for that. Okay, this one it's fine because we already have -2 to 2, and we can hit graph. Now, we don't see all of these because we didn't graph as many, knowing we only needed a few swoops here. So now we're going to do some intersections. Second trace 5. Enter, enter, enter will give you the first one. That's negative. We want to make sure we're looking at the one we're trying to find. So second trace intersection. I'm going to hop over. Again, go up or down to get on the line so you can travel faster. Okay, then enter, enter, enter. So this first one, positive, was the angle we were given. I'm going to put a little star next to it. So now we need that one we just found and the one next to it. Okay, so I'm going to backtrack. Second trace 5. And travel on my line and get closer to the one on the right. Didn't get far enough. Okay. So that's 5.226. And then on the other side, second trace intersection, again, travel on the line. And that was our negative first value. Okay, if we had known ahead of time, we would have written it down, but we weren't sure if this was actually 2. Negative 1.057. Okay, these are the angles that are closest to this angle that make that equation true. Again, there are infinitely many answers. These are just 3 of them. All right? Now, hopefully you notice, this is something that's going to save you some time. With tangent, because the period is pi, these solutions will definitely be pi apart. So you really don't need to graph this. I'm going to have you graph it so you can see these relationships. But this number, if you add pi to it, you get this number, literally plus pi. And if this number you subtract 3.14, you get this number. Okay, so that is a nice little feature of tangent only. Okay, that does not work for sine and cosine. All right. If you have questions on your homework, please come chat with me. These graphs are brand new. I do want you to try to think about learning the patterns for these so you can graph them only using the 4 points. So know the shapes, know thinking about domain and range and some features. Okay, we're going to need that again next class.